All right, and for the last section in chapter 3, you'll notice I have a blank piece of paper here. We are going to be talking about hyperbolic functions, and I'd like to sort of introduce where these things even come from. They're a little weird. Typically, what we do in trigonometry is we base everything on the unit circle. And we have our circle. And then we have our triangles that are based on these circles here. So any given point on the unit circle, that's always a 1. This is going to be y, this is going to be x. And then we base everything on that. So we have that, that y is equal to, so here's our theta. The opposite over that, so that's y over 1 is going to be sine theta. X is going to be cosine theta, and so on. And it's all based on the unit circle. Hyperbolic trigonometry is a little different. Instead of basing it on the unit circle, we're basing it on a unit hyperbola, which is a little bit more complicated. If you remember a hyperbola, and this is a unit hyperbola, so we're going a distance of 1 in both directions. And once again, to label this, this is a 1, 1, negative 1, negative 1. And the unit circle is x squared plus y squared equals 1. The unit hyperbola is of the equation, and we're going to go in the x direction. So we're going to end up with the equation x squared minus y squared equals 1. And that graph is going to look like this. And all of our triangles for our hyperbolic trigonometry are going to be based on this unit hyperbola. So our triangles are going to look like this. And here's our x, our y, our x, and our r. And so that is what this is. So it's when you have the h there, that means it's based on the unit hyperbola. And sinh, this is often referred to, or hyperbolic sine of x is e to the x minus e to the negative x over 2. Hyperbolic cosine is defined as e to the x plus e to the negative x over 2. Notice they're almost the same except the minus and the plus there. And then you can see all of our other definitions for the other ones are there. I'm mostly just going to focus on sinh. We'll talk about cosh or hyperbolic cosine just slightly here. I'm going to use not this paper here because there's not enough space, and I'm going to use this down here to walk through this. So let's talk about our first example. We're going to prove that cosh squared minus sinh, or hyperbolic sine squared x is equal to 1. Notice this is slightly different. In our regular trigonometry, meaning based on the unit circle, sine squared plus cosine squared equals 1. That's a plus. This one's a minus. And if you recall your trigonometry, this almost looks like a double angle identity, but it's not going to be because I'm going to use the definitions. So let's start with the left-hand side. And I'm going to be using these definitions here: e to the x minus e to the x minus e to the negative x over 2, e to the x plus e to the negative x over 2. I'm going to go ahead and FOIL those out. That's going to be in, of course, I'm going to be using the formula. Here, where A in this case is e to the x, B in this case is e to the negative x. And let's see where we go with this. Now, when I multiply these two together, that's the AB. That times that, remember, e to the negative x is 1 over e to the x. They actually cancel out, and I'm just left with the 2. And I got to square the 2 as well. Same up here. And you can see, I'm going to have to distribute a negative here. But you can see what's going to happen is e to the 2x minus e to the 2x are gone. Also, e to the negative 2x minus e to the negative 2x are also gone. And remember, when I distribute that negative, that becomes a plus 2. So this whole thing becomes 2 plus 2, which is 4, over 4, which is 1, which is the right-hand side. So we have proven that there. All right, example 2. Let me scooch that up. Example 2 says, show that the derivative of sinh is equal to cosh. So let's take the derivative. And once again, I'm going strictly by these definitions here. So I'm going to show that the derivative of that is going to equal that. And here we go. Well, the 1/2 just hangs out at that side there. That has nothing to do with the derivative. Derivative of e to the x is e to the x. Derivative of e to the negative x means that it's going to be a negative times a negative when I do chain rule. This becomes plus e to the negative x, which is by definition the cosine, hyperbolic cosine of x. So there's that proof. Now this next one is a little long. It's going to require a bit of work, so I'm going to actually use a new sheet of paper. And we're going to show that. So this is example 3. That the inverse hyperbolic sine of x is equal to the ln of x plus root x squared plus 1. And that's for all. This is for any value of x that's a real number, is what this means. So the upside down a means for all x, and this symbol here means an element of, and this symbol here represents the real numbers. Real numbers meaning no complex numbers. We're not taking square root of negatives. Okay, so we are going to start with our definition. And the way you find an inverse function is this becomes y equals is we swap out the x's and y's. The domain and ranges swap out. And now we have the task of solving for y, which is going to prove to be a bit complicated here. So what I'm going to do is I'm going to rewrite, I'm going to knock that 2 to the other side, so 2x. E to the y minus e to the negative y. Remember, e to the negative y is that 1 over. So I'm actually going to multiply through by e to the y. Actually, before I do that, let's change this up a little. Let's just to make it a little bit easier. I'm going to let t equal e to the y. And you'll note that t is always positive because e to the y is always positive as an exponential function. And we are only talking about real numbers. Because when we get in complex numbers, e to the y can be negative. We're not going to show that today, but that is a possibility. This means that my 2x is equal to t minus 1 over t. Which means what I'm going to have to do is multiply through by t. And I'm going to try to get t by itself. Now, t is not going to be the solution. And you'll note I end up with t squared minus 2 xt minus 1 equals 0. We are now going to use the quadratic formula. Come way back up here. So t is going to equal negative 2x plus or minus the square root. So b in this case is negative 2x minus 4 times a times c. All over 2 times a. All right, so we have 2x, so minus the square root, 4x squared. Remember, when you square a negative, it becomes positive, and negative 4 times negative 1 becomes plus 4. I'm going to pull a 4 out, so that becomes a 2 there. And you can see I can pull out a 2 and reduce that out, and this becomes x plus or minus the square root of x squared plus 1. Now remember, this is t. And if you remember, t is e to the y. Which means that y is the natural log of x. Now, we're not going to do minus because we're only talking about real numbers. So this is going to be plus. And when I say that, if I have x minus this, notice this is going to be just slightly bigger than that. Notice that is exactly x, but I'm adding 1 to it. So this is going to be just a little bit bigger than that always. So if I do x minus something bigger, I'm going to get a negative in the natural log, and we can't have that. So that's why it's only plus. We can justify that. And please note that y in this case is our inverse sine. Hyperbolic sine, pardon me. We have proven it. Super cool. For our last problem of chapter 3, we're doing example 4, and we're going to prove that the derivative of inverse sine, sinh, pardon me, is equal to 1 over the square root of x squared plus 1. All right, so here we go. So we're going to do the derivative of inverse sinh of x, which we just proved is that. And here we go. So remember, natural log is going to be 1 over, right? So 1 over x plus the square root of x squared plus 1 times the derivative of the inside. That's going to be times 1 plus, and here we go. We've done in the past that. So I'm going to use that information. We'll have to do chain rule, of course, for this one. This is going to be plus derivative of the x is 1. Derivative of this here is going to be 1 over 2 times the square root of x squared plus 1 times the derivative of inside here as well. That's going to be 2x. So you may need to take a few minutes, maybe pause the video to kind of try to absorb all of that. There's a lot going on there. I'm going to note that my 2's reduce out. And I end up with 1 plus 1 over the square root of x squared plus 1. Pardon me, x over x squared plus 1 over x plus the square root of x squared plus 1. And there's a lot going on there. Again, double check everything as you're looking through that. I'm now going to multiply the top and bottom through with the square root of x squared plus 1. Specifically to knock out that complex fraction there, that denominator there. So this becomes square root of x squared plus 1 plus x up top. So that times 1 is here. This here, the radicals reduce. I'm just left with the x. This is all over this here. And I want to point out that this is this. They're gone. And so the derivative of inverse sine, hyperbolic sine, is 1 over 1 plus x squared plus 1. Hope that helped.